Hi, everybody. My name is Lee Chinitz. I'm the principal product owner for Wi-Fi at Spirent. Every few years, the Wi-Fi industry goes through a massive change, and that change is happening right now with the move from Wi-Fi 6 into Wi-Fi 7. Wi-Fi 7, which is based on the IEEE 802.11be specification, which is known as the extremely high throughput amendment to the specification, does have a focus on increasing throughput. Wi-Fi has gone through this process over the years of going from kind of basic Wi-Fi to high throughput to very high throughput to now extremely high throughput. And one of the basic ways of adding increased throughput to the specification is by increasing the bandwidth. So again, in the early days, Wi-Fi was focused on 20 megahertz, then 40, then 80, 160 with Wi-Fi 6, and now with Wi-Fi 7, we have 320 megahertz channels. So that's clearly a way of getting increased throughput. But in addition, as always with Wi-Fi, the specification has added new denser modulations. So in Wi-Fi 6, the highest modulation was known as 1K QAM, 1024 QAM. With Wi-Fi 7, we're up to 4K QAM, or 4096 QAM. So more bits per symbol and higher bandwidth gets you much higher throughput, which in the case of Wi-Fi 7 is up in the neighborhood of 30 gigabits per second. The technology that's part of Wi-Fi 7 that we haven't discussed in detail yet is what's known as multi-link operation. This is the technology that's probably of the most interest to most customers, and it's a technology that is adapted from the cellular industry. In cellular, it's known as channel aggregation. And multi-link is really bringing cellular channel aggregation to the Wi-Fi space. So you can have communications on 2.4 gigahertz, 5 gigahertz, and 6 gigahertz simultaneously. You can also imagine sending, instead of different data on the different bands, you can imagine sending the same data on different bands simultaneously. In that case, what you get is increased reliability of Wi-Fi. So if, for example, one of the channels gets interfered with, it's extremely unlikely that another channel is going to get interfered with at the same time. And so the data will get through on one or the other. What you then have is the ability to put that data back together, and even if you've lost certain packets on one band, you've got them on another band. So now you have increased reliability. With multi-link operation, though, if a channel is interfered with and the device has access to another channel in a different band, that again is statistically unlikely to be interfered with at the exact same time, the packets can get through on that other band. So again, you can see there how you can improve latency. With something like multi-link operation, where you have these extremely high bandwidth links, you can now imagine having very high bandwidth AP to AP backhaul links. So you can have very high performing mesh networks. So multi-link operation is probably the area of the most interest to our customers in Wi-Fi 7.
Welcome to 2030, where Network as a Service has revolutionized the way we do business. With NaaS, businesses can scale their network on demand, ensuring they always have the speed and capacity needed without hefty upfront costs. Gone are the days of managing cumbersome and disjointed network hardware. Everything is built to work together and transparently managed behind the scenes. From retail to manufacturing, businesses enjoy enhanced connectivity that allows them to serve customers faster and innovate continuously. Scaling has never been easier, leading to higher productivity and cost efficiency. With built-in advanced security features, automatic updates, and AI management, Network as a Service is the backbone of business operations. Which networking companies led the transition? What's common in their success strategies? Join our 2024 NaaS showcases and download our reports.